Math 3, Unit 11, Section C. So today we're going to talk about graphing log functions. Okay, so this whole year we have been dealing with graphing a lot and how you move and shift things. And so that is basically what we're going to do today. So this first example I'm going to show you is kind of like your standard equation. Do you guys remember how you would change this into exponential form? Okay, so I think that sometimes when you're changing it to exponential form, if you think of the equal y is on the other side, when you change this to exponential form, you take your base, which is 2, and then it goes 2 to the y power equals x. Do you guys remember that now? So it's always whatever the base is of the log, it goes to this power, and it equals that number there. So if you're going through here, what value would you need for y in order to make the answer 1? 0. Okay, 2 to the 0 power equals 1. What would you need for your exponent in order to make the answer 2? 1, good. And then what would we need for it to be 4? 2. And then the next one would be 3. What about to make it 1/2? Do you know what would go in the exponent? I think I heard someone say back there, -1. Because remember when you have a negative exponent and it ends up flipping the number, right? You change sides, we make it into a fraction. And so 1/4 would be -2 and 1/8 would be -3. Good. So we're going to go ahead and plot these points on the graph. And so the first one, 1, 0, we go right 1 up 0, make our point. We go right 2 up 1, right 4 up 2, and then 8 is up 3. And then at 1/2, so 1/2 is in between 0 and 1, and it goes down -1. And then 1/4 goes to -2, 1/8 goes to -3. Do you think there will ever be a time where this answer could equal a negative number? Could you put any exponent here and get a negative answer for x? No is the correct answer. Okay, because when you have a negative exponent, it makes it a fraction. It just makes it a smaller number, but it will never actually become negative. And so what that means is that there actually is like an asymptote here at 0. And so remember that asymptotes are where basically this graph will get really, really close to 0, but it will never actually cross 0. It will never touch it. Okay, and so for all log functions, the graphs ends up having kind of this same shape where they get really close to the asymptote and then they kind of slowly get bigger that way. Okay? So when we answer these functions, what is the domain of the function? And the domain is dealing with which values? X. And so with the x values, what do you think the domain is? All the x values are what? Good, so we can write it 2 different ways. Okay, does it ever touch 0? No. So 0, comma, to positive infinity, or you could say x is greater than 0. So both of these answers are acceptable. Okay, the vertical asymptote, that is where? 0, but you have to write it as an equation, and so it's x equals 0. This line is at x equals 0. Okay, what is the range? So range is dealing with the y values. Okay, make sure you're doing this with us. I see some of you doing other things. This will be on your final, okay? And you are responsible for this homework assignment you're going to get. And I'm trying to make it so it's super easy and you might be able to finish it pretty quickly, but if you're not paying attention, it'll be tough. Okay, all right, so what is the range? The range is the y. What do you think is going to happen with all the y values? Yeah, it's basically all reals. Or if we were using interval notation, that would be negative infinity to positive infinity. So it's using all of the y values, okay? So now we're going to go to our next one, and what do you notice that's different about this next problem? Good. It has a -2 here at the end. What do you think that's going to do to the graph? Very good. This -2 is going to end up shifting down 2. Remember that when you have something in parentheses with the x, that's when it's shifting it right and left. Do you guys remember that? Okay. So this is my suggestion. And there's more than one way of doing it, but I feel like this is the easiest way. So I'd like you guys to end up marking just 2 points. If you were to rewrite this, notice this one has a base of 3. I'm just going to write this as 3 to the y equals x. What that means for my points is that, first of all, you will always have a point at 1, 0. And the reason is when you plug in 0 for y, no matter what your base is, you always get 1. Because anything to the 0 power is 1. So every graph starts with a point at 1, 0. The other point I'd like you to plot is if you were to plug in 1 for y, you would end up getting what? If I plugged in 1 for y, what will I get? 3 for x. Okay, so those are the 2 points we're going to match or kind of put on here. And so what I'm going to do at 1, 0, I'm not going to make a point. I'm just going to make a little x because we're going to have to shift our graph. So if this didn't have any shifting, the first point would be at 1, 0, and the second point would be at 3, 1, and the asymptote would be still at the x equals 0. Is everybody okay with that? But we are going to shift it down 2. So from each of these points, I'm just going to go down 2 and make a point. From here, down 2, make a point. If you're not shifting right or left, your asymptote is going to stay at the same value. So I still have my asymptote at 0, and then your curve will get, I didn't draw mine great, but it's going to get very close to 0 and go like that. Okay, so what is the equation of the vertical asymptote? X equals 0. What will be the domain on this one? Good. X is greater than 0. Notice it's not greater than or equal to, it's just greater than 0. And then the range would be all reals or negative infinity to positive infinity. And I'll go ahead and put this one here to 0 to positive infinity. Okay, any questions? Okay, so on this next one, what is this +4 inside? How is that gonna change our graph? Very good, it's gonna go right 4. So once we have our points, we're gonna end up shifting it to the right 4. Remember, whatever's in parentheses always ends up becoming the opposite, okay? So if I were to change this, kind of into exponential form, it's going to end up being what? Good. 5 to the y equals x. So my 2 points, my first point will always be at 1, 0. And then the second point would be at 5, 1. When you plug in 1 for y, you would get 5 for x. And so we're going to go 1, 0, make an x there because it's not our actual point, and then go to 5 up 1. So when we go right 4, and if you think about originally 2, my asymptote is at 0. So if I'm going right 4, where will my asymptote be at? Positive 4, right? We're going right 4. So there's my new asymptote. This point, we're going right 4. 1, 2, 3, 4. So this is where my actual point is. And then here, this one will go right 4. And then again, it gets close to the asymptote, and then it curves that way. Ish. I'm just having issues drawing. Okay, So what is the equation of my vertical asymptote? X equals 4. Now on this one, the domain is going to be what? 4 Good, 4 to positive infinity, or x is greater than 4. And then what is the range? Good, it's still negative infinity to positive infinity, or all reals. Okay, does anybody want to ask me questions? Are we okay with everything that's happened? Yeah?
We're just talking to
Yep, just the 2 points, and then drawing your curve, and make sure you understand where your asymptote is. Okay, so if you turn it over now, do you remember what it means when you have a negative there in front of the x? It's going to reflect over which axis? It's the y-axis. Okay, so that negative there means you're reflecting over the y-axis, and then this positive 3 means what? Good, up 3. So when we write this one to begin with, this would be what? 2 to the y equals x. So my points are going to be what? 1, 0, and 2, 1. So we go to 1, 0 and make our x there, and we're going to go to 2, 1. So we have to do 2 things this time. We have to reflect over the y and then move it. So if this is my point, if I'm reflecting over the y, where am I going to go? So how many does it take to get to the y from here? 1. And so that means I'm going to go 1 on the other side. So that's my reflecting. I'm at negative 1. And then where will I go? I have to go up 3. So I reflected over the y, and I'm going to go up 1, 2, 3. And this is my point. Do you have questions? So on this 2, where am I going to go for reflecting over the y? To negative 2, good. And then we're going to go up 3. So negative 2, 4 is correct. And then, did my asymptote change? No, it's still at 0, because we're just reflecting over the y-axis. We're actually, in a way, reflecting over the, we're reflecting over the asymptote too, I guess. So if you need to, we know that this one would originally be like this, right? That would have been our original line. Well, we reflect over and move it up. So see, it's still getting, it's still getting close to the y-axis, and it just looks like that. So all it's done is gone from here, flipped over, and moved up. Are we okay? And if you have your phones and you want to plug some of these things into Desmos and see what's happening, you can. Sometimes, like, knowing that it's correct by plugging it in is helpful. Okay, so what is the equation of the vertical asymptote? X equals 0. Okay, now what will I do for the domain on this one? Good. X is less than 0. And if you're writing this out, it would be negative infinity to 0. Because you always start left and go right. And so you'd be starting at negative infinity going all the way to 0. What would be my range still on this one? All reals or negative infinity to positive infinity. Okay, questions?
Is there ever a range isn't all reals on these problems?
I don't think so for what we're doing. No. Yeah.
At the beginning, when you get your point, it's 2, 1.
So if you plug in 1 for y, so I'm doing is plugging in, I'm really just plugging in 0 for y. Anything to the 0 makes 1. And then I'm plugging in 1 for y. And 2 to the first makes 2. So basically, whatever the base is, it's going to be that number, comma 1 is your other point. Okay? All right, so on this next one, what does that negative mean?
Reflected past x-axis.
Very good. And then this plus 2 right here, what does that mean? Very good. Left 3.
2.
Thank you. I need more coffee. Okay, left 2. Okay, so if we were to rewrite this one, this would be what? For our basic equation, it would be 3 to the y equals x. So I'm just kind of taking out the shifting, just rewriting what it would look like if I didn't have any shifting in it. And those points would be what?
1, 0, and 3, 1.
Good, 1, 0, and 3, 1. So we're going to go ahead and mark those, 1, 0, and then 3, 1. And if you want to, you can kind of draw like a dotted line for you to visually see, okay, this is what it's going to look like before I do everything. Okay, so now we're going to move it so we can get our actual graph. So if I'm reflecting across the x-axis, what's happening to this one? Staying there. Good, because it's on the x-axis. And then we have to go left how many? 2. 1, 2. What happens to with my asymptote? Where did it go? So it was at 0 and it's going to go left 2. So it's now at negative 2. Good. Now, reflecting over the x-axis, where does this point go? It's going to go to negative 1. See how it's 1 away from the x-axis? You go, when you're reflecting over, you go 1 away on the other side. Okay, and then from there, I've done the reflecting now, and I go left 2, 1, 2. And here's my point. Okay, so what do you think is gonna, what is this graph gonna look like? So you know how on this one, it's getting close to the asymptote going down. So instead of it being close going down, it's gonna be close going up. And so it just, this is what it looks like when it's reflected across. And sometimes I feel like if you see where the original one, like if you think about reflecting it and flipping it, you can kind of see it better. Okay? So what is the equation of my vertical asymptote on this one? Good. The domain would be what?
X is less than
It's going to be negative 2 to infinity, or x is greater than negative 2. And what is the range? All reals, good. Or negative infinity to positive infinity. Yes?
Wouldn't you, when you reflect, wouldn't you only reflect -1? Or -1?
Just at negative 2.
Oh, you're right. I just didn't plot it very good. Thank you. It should be right there. Thank you. Okay, we're good. Anything else? All right, last one. So this right here means what? Good. Right 3, and then this means up 2. If we look at our original function before any of the shifting, it would be 4 to the y equals x. So my points would be at 1, 0, and 4, 1. So 1, 0, and then 4, 1. So from each of these points, I'm going to go right 1, 2, 3, up 2. And then I go to this one, right 1, 2, 3, up 2. Okay, where is my, and if my asymptote was originally at 0, I'm going right how many? 1, 2, oops, 1, 2, 3. So that means my asymptote is at 3. And then we draw our curve. So the equation of the asymptote is x equals 3. Make sure you do x equals. The domain will be, very good, 3 to positive infinity, or x is greater than 3, and the range will be, perfect, negative infinity to positive infinity. Okay, any questions?